Welcome to this week's episode of the DevOps Lab. We have episode 3 with Matty Stratton back from Pulumi, and then we also have Kat Cosgrove joining us as we talk about infrastructure as software using Pulumi and GitHub Actions. So tune in. Welcome to this week's episode of the DevOps Lab. We're back again, and we're going to talk about Pulumi. And I have 2 special guests with us. Welcome, Matty, and welcome, Kat.
Hello.
Really good to have you both back. Kat, can you take a minute and tell everyone out there what you do for Pulumi?
Yeah, so I'm a staff developer advocate at Pulumi, which ultimately means that my job is to teach people about infrastructure as code in general, but also if they're interested specifically how to use Pulumi if I think it is a good fit for them.
Awesome. Well, welcome to the show. And we have Matty back with us. So Matty, welcome again. So tell everyone out there that may have missed the last episodes, what is it you do for Pulumi?
The fun thing is I do exactly what Kat does, except, maybe not as amusingly. I don't know. Maybe Kat's funnier than I am. We'll find out. We've got 20 minutes to find out who can be funnier. But no, I'm also doing developer advocacy at Pulumi and just try to help people see how treating their infrastructure as software can make things more awesome. Come on streams like this and just hang out in the community, and we'll see you out there.
Wicked. Well, we're gonna have a judge. We're gonna have a little judge from the audience who's funnier at the end of this video. No, just kidding. So awesome. Let's get down to it. Let's talk about Pulumi and awesome stuff it does. I'm a big fan of infrastructure as code, so I'm really excited to have you all on. So today we're going to talk about having infrastructure software with Pulumi and deploying it with GitHub Actions. So go ahead and take it away.
Yeah, I'm going to give a little recap, and then I'm going to let Kat kind of talk about how we want to do stuff. But just for catch up, this is the third DevOps Lab that we've been on. So just sort of building. I don't want to assume that you all have watched them all, but why would you not have? Because, building.
Because Matt's so funny.
Because I am so funny. But in our first episode, we used Pulumi to write some code to deploy an Azure VM. And then the last time we said, hey, wouldn't it be great if we put some tests around it? And then what we want to do now is let's put this all in a pipeline. So we're going to do a review of kind of what we'd had. But Kat, maybe talk a minute about why those 3 things matter.
So those three things matter because they are all core pieces of building and actually deploying an application. While you can manually deploy everything every single time from your console without a CI system in place to automate things like running your test, standing up new infrastructure, and actually deploying your application, that's slow. And also it kind of sucks. It's boring. And humans are really, really prone to making mistakes when we do the same thing over and over and over again, because we get bored and we get distracted and we have bad days, and your CI pipeline does not have those problems. So this is also cool because doing it with Pulumi in a pipeline allows us to test our infrastructure, which is rad and something that is now a lot easier to do than it used to be. In some ways, it was previously impossible. And now it is both possible and pretty easy. So
definitely.
Great. Why don't we pull up my screen? I'm going to kind of walk through. And so this repo here, Awesome Azure, this is the code that we've been working on over the last couple episodes. Now, not all of the different kinds of files you will see in this repo are necessary for a Pulumi program, because never write software the way that I do. But one of the things we didn't really touch on a little bit when we talked about one of the cool things with Pulumi is that when you write a Pulumi program to describe and deploy your infrastructure, you're writing that in a general purpose programming language like TypeScript or Go or Python or any of the .NET languages. So you'll see, right, for example, so I wrote this in TypeScript. So this index.ts here, this is my Pulumi program that is going to go ahead and deploy our VM. And I'm going to go over this kind of quickly, because if you want to really see how it works, go head back to that first DevOps Lab episode, go back to the back catalog. But we do a couple of fun things here. So we're using these packages that are coming in. And so one of the things that's important is this idea of a native package in Pulumi. So because we're using what's called the Azure native package, this package, which in this case is a node package, but it could be a Go library or anything, these are built basically daily according to the open API spec that's published from ARM. So as soon as something is available in the Azure API, Pulumi supports it like within 24 hours, pretty damn close. So that's really powerful. But all we have to do is when we bring these in, we can start creating objects. So we do things like we need a resource group. We need to create a virtual network. We're giving it a public IP. This is all this, and we're doing, our web server is not super exciting. The way it's running is just running the Python built-in web server just to echo hello world. But we do a little bit more. So we can see all of these things that we're building with our infrastructure as software. And then we do export out what the public IP address so we can use elsewhere. The couple things I want to call your attention to are because these are objects. So we created an object called resource group name, right? And then we refer back to it later. So we don't have to, when we're creating our network interface, and we know the resource group we wanted to go into, we don't have to know the name of it. That's because we're writing this in JavaScript and TypeScript. We can use things like variables and stuff, and we can use loops. Now, I want you to notice one thing. So we have a tag on here. We're saying, okay, we're going to give our VM a name. Now, so that tells us what our Pulumi program will do. The next thing we're going to look at is we said we had some tests, right? We wanted to be able to run tests. So in this case, because our Pulumi program is written in JavaScript, we're going to use Mocha, which is what testing framework. You can use whatever testing framework your programming language supports, which is one of the pretty dope things about writing infra code in a general purpose programming language is you have the whole ecosystem of that programming language. So what we're doing here is this is a unit test, which means we're mocking it. So we're not actually really running Pulumi and creating a resource. We're pretending to, and we're saying what would happen. And our test is we said, we want to make sure that every server that we create, it has to have a name tag. We don't want to write infra code that will create servers without name tag, VMs without name tags, because then how do you know what they are, who they are, who to go yell at when they forget to turn them off? So this is saying if we're missing a name tag on the server, then if it doesn't have this tag, then say it's okay. So now what we did last time is we ran that locally, right? Mm-hmm. I could, on my local machine where I'm running this, I can run the test before I push it up. Now we want to bring it into our CI/CD, and which means we want to bring it into our pipeline so that every time we push code, we're going to actually see this test run. So then there's two things. So I'm going to show you two of the workflows that we've built, and then we'll kind of talk them through. So the first one is the one that's the test. And this is in a GitHub Actions. So if you haven't used GitHub Actions before, they're pretty easy to use. Even I can use them. You can build them with a template. In this case, I actually built this one using just sort of a default template for Node application, because that's fundamentally what this is, right? Yep. And so what we're saying here is the first thing is we're saying, what do you do, right? We want this when we are either pushing to main. So anytime we're merging or pushing directly to our trunk, we should run this test, but also pull requests that are against the main branch. Mm-hmm. Okay. And now in this case, we could do a matrix build if we want to test against lots of versions of Node. We don't really need to do that here. And what is happening here is we said, okay, we need to have Mocha installed. We get our npm install, and then we run npm test. And if you aren't familiar with how Node works, in our package.json, we have a script which is test. We say if you run npm test on this package, it should run this. This is basically, you could also do this running it at the command line. It's a little cleaner to run it this way, because then, if you're lazy and don't want to type.
I'm lazy.
Very lazy.
Totally.
So Kat, like, so that was just sort of seeing the test. Like, how do you, when you think about like, I know it's going to sound a little silly, but like, why do we care about like enforcing testing in our pipeline here?
Because again, humans are bad at this, and computers are not bad at this. There are all kinds of things that could go wrong that you can't really anticipate. So it's important to make sure that core functionality, like your infrastructure, is actually there and operational, at least as far as the rest of your application code expects to be able to interact with it. If you just trust it and ignore that, like, sure, it might be fine, like most of the time, but you're not going to know until it's actually live in production whether or not it's going to work. And that's kind of horrifying, at least to me. So you want to make sure before you actually like merge into main and your application is out there for your users, that your infrastructure is actually there and your application can interact with it the way it's supposed to be interacting with it. Otherwise, you're just going to push a bad update and everything's going to go down, and it's going to be horrible and embarrassing and stressful, and you're going to page all of your engineers at like God only knows what time, and they're all going to be really mad at you, and I don't want to deal with that.
You want to have
and I think also, I mean, there's business reasons why as well. Like if we push something to production, not only do you look bad, it adds risk.
Yep.
It also adds cost to whatever it is you're doing, you know, as an organization. And when you're writing infrastructure as code, if you mess something up and you're automating something, if you're not running a test with it, you could absolutely destroy everything. And I've seen people like deploy something and it disappears or breaks everything. And, you know, we've all done it. So yeah, testing is important. And it's something that, especially with infrastructure as code, used to be really hard. And we didn't do a lot of it. We'd be like, oh, let's see what happens when we push this little button. It's so much better. It's so much more inclusive so that when we run that CI pipeline, we know exactly what's going to happen and when. And we have a lot of organizations when they go to the cloud are like, well, we can't, you know, we have compliance. It gives you full traceability. That's the other thing. Like compliance is such an easier discussion to say, well, if you put in the right testing and procedures for your CI and CD pipelines, you fulfill that compliance and you have that full traceability instead of going through who pushed what button when and looking at AD logs, you know.
Absolutely, everything is logged, which is rad. And like
awesome.
Most engineers are going to take down production at some point, right? It happens. It's just like it's part of what happens, and it's deeply embarrassing the first time you do it. But you want the story to at least be good the first time you take down production. You don't want it to be because you decided not to test your infrastructure. That's not a fun story for Twitter.
Yeah,
it's going to happen.
It's gonna
So I want to show one more workflow, and then we're going to sort of go through this. So the other thing, so this, what I did so far was just the same thing you could do. It's just some fun node testing. But Pulumi has a GitHub action itself, has a GitHub action app, which you can use. You don't have to use it. But so what we wanted to do here is say on a pull request, run a Pulumi preview. So if you remember in the past, when you run Pulumi up, before it applies your changes, it just shows you, basically, I don't want to say it's testing your application. It's not, but it's making sure that it'll run, right? You know, it's sort of, does this compile? Does this run? Does this execute? And it'll tell you what it would do. That's a Pulumi preview. So we said we want pull requests to run a Pulumi preview. So that means every time there's a pull request, it's not going to touch my Azure infrastructure, but it's going to tell me what would happen. So what we do there is I've set the secrets. So this is one of the things you can do with GitHub Actions in the settings on the repo. You can set an encrypted thing. So I needed to have the Pulumi access token. It needed to know my Azure credentials to be able to do that. And it's just going to run a Pulumi preview. So what I'd like to do now is we're going to say, let's try this out. So we're going to do two things. Right now, if we did a new pull request, my tests would pass because we have a tag, right? We have tag named Floyd. So we're going to create a PR that's going to have a breaking test. And after I start the PR, we're going to do a little quiz because I'm curious. We're going to see if Kat and April can predict what the GitHub Actions will do when we get rid of our tag, what our result is going to be. So we're going to say break production like a real engineer. Okay. We're going to create a new branch. That's going to give us our pull request. This breaks stuff. And also here's a detailed description.
But you're already a good engineer because you're putting in notes.
I know, that's what I was trying to think about like the snarkiest way I could say like lorem ipsum or hipster ipsum in here or something. So we're going to create, there's also startup ipsum, which I really like.
Oh, Lord.
Okay, so if we take a look, it's building up our 2 checks right now, right? So it's doing the Pulumi preview and it's running the unit tests. And it's going to take a second to kind of go through this. They're in progress. If we go take a look here, we look at the details, we can see it's running, it's setting up, it's running all through those pieces. So this is how GitHub Actions work, right? You've defined things, but what's fun is you notice they're happening in parallel. Okay, yes. Which in this case is fine, right? But we can make that, like if I was, let's say I didn't even want to bother running the Pulumi preview if the unit tests failed, which honestly I might want that. I could create a kind of a not a dependency on the other one or build them into one workflow file. In this case, it just seemed efficient to do them both at the same time. And the same thing, if we go look at our Pulumi preview, it's going to run npm install, which takes, a few minutes. Okay, so so we can see that it's gotten that stuff in there, and now it's actually going to go ahead and it's going to run our Pulumi preview against that. Okay, so before we can see. April and Kat, what do you think is going to be the result of these 2 checks?
Surely they will succeed.
Fail. No, tests are going to fail. You ran
tests
a
are
test,
definitely going to fail.
It's going to work.
Okay.
It's going to pull out that you forgot the tag.
So what happens is you'll see that actually the preview was successful, which is fine because the preview is not running the test. The preview is saying, if you were to run this, this is what it would do. It would create all those things, right? But our unit tests failed. And if we were to go into that, we can see it says error, missing a name tag on the server.
Nice.
And then we got out of there. So one last thing that's kind of fun. So we'll see, this is the Pulumi bot leaves this. If I look at the update and I click on this, it takes me into my Pulumi account for my stack. And I can see the whole run of my there's no diagnostic, the diff, right? I can see all the details of what would have happened. But if we look at resources, we'll see there are no resources under, it didn't create any resources because we just did a preview, right? But if we were to that, and then again, we look into the activity, we can see that I ran this preview. You can also see that I was testing this right before the stream, but that's fine. And like I said, if we wanted to, we could go ahead and we could make this actually deploy the infrastructure when we merge this to main. So, but if we wanted to fix this, we would, of course, just go back in and we would just add our name tag. We know that's going to pass because,
because we've seen it pass.
Because we've seen
but
it.
We should still test it.
We should still test it. Okay, so let's go ahead and we're going to edit the file. And where did the VM go? It goes down here.
I feel like we need to spin up a GitHub code space for you, Matty.
No, I should have actually just done this in there. And the other thing I'm going to do is I'm going to say, because right now the change I made is going to actually show no diff because I put it right back. But we go ahead, we add that. We should see we made our commit. We should see that it changed. Yep, we added our tag back. And then if we look back at our tests, they're going to run again. And then when it's done, we'll see the result. But
and this is where, as a good engineer, after you failed that test, it won't allow that merge, that pull request to main, and it won't go to production. So you should have those guardrails in place for the folks running your infrastructure as code to say, oh, didn't fail. It failed the test, didn't pass all the tests. We're not going to push it, which would be really good practice as an engineer to not push broken code.
Correct. I mean, I push broken code all the time, but I don't merge it into main.
Yeah,
you know?
Absolutely. Absolutely.
I think it's like, yeah. So like if we could create, I know we're getting ahead of ourselves on what, but this is I think what we're talking about is requiring status checks to pass, right? So we could say match against main, and you can't merge unless the stuff goes. And you should also do this check, because just because you're an admin doesn't mean that you get to do whatever you want. That said, do as I say, not as I do. Cool. So that's sort of chugging away. Kat, you want to kind of
recap the whole situation?
Yeah.
So we've taken an application that Matty has built slowly over time, over 2 episodes of this, and taken it from nothing, just an application that we stand up with Pulumi, to something that we also test with Pulumi, to something that now exists entirely inside of your CI pipeline, so that every time you make an application update, your infrastructure is going to be stood up as part of your CI, and it's going to be tested as part of your CI. So you can be sure that every change you make to your application infrastructure is absolutely there and working as intended by the time it makes it to main, because you've got this safety harness, which is great because for the 1,000th time, I think I say this in like every talk I give too, humans are super bad at repetitive tasks. So it's really important that we take these things out of your engineers' hands, and that we also know if something does go wrong, we have a record of every step along the way. Everything that occurred to lead to some kind of infrastructure failure, we know about in one way or another. Because when something goes wrong, you got to go fix it, right? Yeah. And you can't begin to unravel it if you don't really know what went wrong. You don't have an idea of where to start. So this all helps you make sure that everything is packaged up nicely, everything knows where it lives, everything is healthy, and if something does kind of fall over, it's easier to track down why it fell over.
Absolutely.
I want to add one thing that we didn't touch on, but I think it's helpful to know, is we showed an example of where the only thing in this repo was the infrastructure code. Mm-hmm. But you absolutely can sidecar your application code in your infrastructure. So you could have
which is repo, what I do.
Which is a more common use case. Yeah. If, again, it depends on how you're doing. Maybe you're building the systems for other people. Maybe you're doing that. But you could have, for example, in your repo that has your Node app or your .NET app or your whatever app, it doesn't even matter. We'll have a folder maybe called infra that has the Pulumi program in it. Yep. So that whole repo that can be running the checks on your application can also be checking your infra code. And then also, like we said, on merge to main, also, as we said, on merge to main, it can then actually deploy the infrastructure that your application needs.
Yep. This is how I build my personal website. I have a separate directory for my infra code and a directory for my actual website code. And all of it happens within the same repo. All of it happens in the same pipeline. And I don't have to worry about it. All of it gets tested every time I update anything. It's pretty rad.
Awesome. And there's also things you can do with branching policy. So if you're not touching the infra, but there's a dependency, it will test the infra and how your code affects it, but not having to run everything. So Kat and Matty, thank you both for being on the DevOps Lab. Really excited to finish off this episode 3 of using Pulumi in Azure. So if you guys haven't seen the first 2 episodes, please go check them out. Matty walks you through how to deploy Pulumi as infrastructure software and then goes over testing more in depth. So thank you everyone for joining today, and see you next time on the DevOps Lab.